today we're going to cover Chapter 7, Section 5. It is the last section of Chapter 7. Today we're going to talk about properties of kites and trapezoids. Now, what's different about the trapezoids and the kites is they are not parallelograms. They're quadrilaterals. They have four sides, but they're not parallelograms. So let's first take a look at our definition of a trapezoid. So a trapezoid is going to be a quadrilateral with exactly one pair of parallel sides. If it had two pairs of parallel sides, then it would be a parallelogram, and it is not a parallelogram. Each of the parallel sides is called a base. The non-parallel sides are called the legs. The base angles of a trapezoid are going to be two consecutive angles whose common side is a base. So notice in my picture, my bases have the parallel mark, the arrows on them. The legs are not the parallel sides. Your picture, or when you get a picture of a trapezoid, it may not always be sitting on its base. So what you're going to look for are the parallel marks to know which ones are going to be the bases and which one are going to be the legs. Next, we're going to talk about a special trapezoid. One is called an isosceles trapezoid. And this one, if the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. So again, you can see the bases are the sides that have the parallel mark. And then the sides that don't have the parallel mark, that's going to be a leg. And when the legs are congruent, it's an isosceles trapezoid. So the isosceles trapezoid has some theorems that talk about some properties of it. So the first one, it doesn't have a name, it's got a number, so we're not memorizing the number. The first one is called the isosceles trapezoid base angles theorem. So this one's the isosceles trapezoid base angles theorem. I'm just going to abbreviate theorem as THM. So this one states that if a trapezoid is isosceles, then each pair of base angles are going to be congruent. So in this picture, you can see the bases have the parallel mark, and then that would make each angle on the end of that base, angle A, is going to be congruent to angle D, and then angle B is going to be congruent to angle C. All four are not congruent. If they were, then they would be right angles, and it would be a rectangle. So here, just the base angles on the ends of each base are going to be the congruent angles. Then the second one, if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. This is the isosceles base angles converse. So isosceles trapezoid base angles, and instead of the theorem, it's the converse. We've switched the order. And then the last theorem, so this one states that if the trapezoid has a congruent pair of base angles, so here in the picture we're given that A and D are congruent, so then we can tell that those sides opposite those congruent angles, those legs, are also going to be congruent, making it an isosceles trapezoid. And then the last theorem is called the isosceles trapezoid diagonals theorem. And this one states that if a trapezoid is isosceles, if and only if its diagonals are congruent. So this one here, you can see that if the trapezoid ABCD is isosceles, if and only if diagonal AC is congruent to diagonal BD. Next, we're going to talk about the mid-segment of a trapezoid, and this is going to be the segment whose endpoints are the midpoints of the legs. So again, these are our legs. Leg. We would have parallel marks here. And this point here is going to be a midpoint on either side. And we can tell it's a midpoint because of the congruency marks. We know that a midpoint splits a segment into two congruent pieces. This is the definition of a midsegment, and it tells you how it's formed. The next slide will have the theorem, and it's going to tell us how to calculate the measure of the midsegment. So the theorem for the midsegment states that the midsegment of a trapezoid is parallel to each base, and its length is 1/2 the sum of the lengths of its bases. So this is sort of like an average. So this is going to be parallel to each of the bases. Now I'm going to simplify this. I'm going to add in a variable here. So I'm going to say that BC, this base is base 1, and then AD will be base 2. And I'm going to, instead of using all these segments, I'm just going to have a generic form here. And I'm going to state that the mid-segment length is going to be found by doing 1/2 base 1 plus base 2. Or you could also just do base 1 plus base 2 divide by 2. So you can either multiply by 1/2 or divide by 2. So be able to use this formula to find the length of a midsegment, or if you're given a midsegment and one of the bases, be able to find the other base. So be able to use this formula. And we're going to do examples at the end of the notes. When you go to name your trapezoid, we don't have a little shortcut where we could just draw a picture of a trapezoid. So if I were to name this trapezoid up above, you have to write the word trapezoid, and then you have to list the 4 vertices. It doesn't matter where you start. I'll just start alphabetically, and then you just go around the sides. So when you name a trapezoid, you have to write the word trapezoid in front of the 4 capital letters. We're going to see the same thing on the next slide. When we name a kite, instead of writing the word trapezoid, we're going to write the word kite in front. Okay, so the definition of a kite is a quadrilateral with exactly 2 pairs of congruent consecutive sides. So what this means is consecutive means in order or right next to. So notice in my picture here, I have a congruency mark here on AB, and then the consecutive side that it's right next to that's also congruent would be AD. And then over here, BC, and its consecutive side would be CD. So it has exactly 2 pairs of congruent consecutive sides. In the kite, opposite sides are not congruent, consecutive sides are congruent. If opposite sides were congruent, it would be a parallelogram, and kites are not parallelograms. Notice how they named the kite down at the bottom. They went in alphabetical order, but again, it doesn't matter. You just pick a starting point. You're going to write the word kite when you're referring to a kite. So you would say kite. Let's say instead I decided to go backwards and say A, D, C, B. You can't jump across the figure. Just go pick a starting point and then go around and write the letters in that order. Next are 2 theorems for kites, which are also properties of kites. If a quadrilateral is a kite, then its diagonals are perpendicular. Remember, in the square and the rhombus, the diagonals are also perpendicular. And remember, perpendicular lines form right angles. So in this picture of the kite, when diagonals are drawn in, realize that you're creating 4 little right triangles within that kite. Then the second theorem, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. If both pairs were congruent, then it would be a parallelogram. And again, a kite is not a parallelogram. So only 1 pair, and that pair is formed when the 2 non-congruent sides intersect. So in this picture, B and D are the congruent angles, and notice they're formed by the 2 non-congruent sides. However, A and C would not be congruent angles. When you're doing the homework tonight and you're looking for missing angles in a kite, remember the angles of a kite, because it's a quadrilateral, are always going to add up to be 360. Use the fact that it has a pair of opposite angles that are congruent when you're trying to answer the homework questions. Let's try example 1. All right, next, let's try an example. Now, notice this trapezoid is not sitting on the parallel side, so it's not sitting on its base. So the parallel sides, remember, these are our bases. And these are the legs. This is a leg, and this is a leg. Now, if it helps you to stand it up, you could stand it up if you want to see it sitting on its base. You don't have to. C, D, B, A. This was parallel, parallel. This one was 100. So I know when I have an isosceles trapezoid, I know that my base angles are going to be congruent. And then A and B are also a pair of congruent base angles. Now it wants me to find the measure of angle A. Now I can go about doing this 2 different ways. I'm going to show you the short way first. So remember, since you have parallel lines here, so since CD is parallel to AB, then I could use AD as a transversal, making angle A and angle D consecutive interior, which are supplements. So to find the measure of angle A, all I have to do is 180 minus 100, and angle A will be 80 degrees. And so will angle B, because these are the congruent base angles. Now, the longer way would have been to, I know that this one's 100, and then these are congruent. So I could have also used the fact that a quadrilateral, the angles add up to be 360. So I can add the 2 that I were given from the beginning, subtract that sum from 360, and I'm left with 160. And that's going to be the amount that is shared between A and B. So I have to divide it by 2. And then I get 80 that way as well. That's the longer way. It's a lot faster to use the fact that you have consecutive interior angles there. Here we go. Next example. Same thing. Notice again, it's an isosceles trapezoid. I have congruency marks on the legs. So what I can do here, again, use the same information that these base angles are congruent. So this one would also be 49. And then I can use the fact that I have parallel lines again. And now to find the measure of angle F, use EF as a transversal. And I know that E and F are going to be supplements because they're same side interior. So all I have to do is 180 minus the 49, and the measure of angle F and G is 131. You could have also done it the long way, where you take the 2 base angles you had from the beginning, add them, subtract from 360, and get 262, and then divide that by 2, and you get 131 that way as well. So it doesn't matter. There's always more than one way to do some of these missing angle measures. That's the longer way. The next example, again, another isosceles trapezoid. And notice this time, they're giving me information about the diagonals. And when it's an isosceles trapezoid, I know that my diagonals are congruent. So this tells me that FJ is going to be, KJ is going to be congruent to MF. And they're telling me that MF is 32.7. So that tells me also KJ is going to be 32.7. So let's go ahead and fill this in. So since MF has a length of 32.7, so does KJ. Now they're also giving me the length of KB, and it's 21.9. So this is 21.9, but the whole thing is going to be 32.7. So what I need to do here is find this piece here, which is going to be the same as this piece, which is what I'm looking for. And the way that I can do that is to take the measure of the whole thing, the 32.7, and subtract the piece I already have, the 21.9. And I get 10.8. So the measurement of FB and JB are both 10.8. Because this one is also 21.9. So FB equals 10.8. So our next shape is a kite. They're telling us in kite ABCD, the measure of angle DAB, which is going to be located right over here, that angle measure is 54 degrees. So the whole thing is 54. Then they're also giving me the measure of CDF, and CDF is right here. So this angle measure is 52. And they want me to find the measure of BCD. And BCD is this one up here. Now, I also know in my kite, I've got congruent consecutive sides. So BC would be congruent to CD. AB would be congruent to AD. I also know that my diagonals are perpendicular. So I've also got 4 little right triangles here that are formed by those diagonals. Now to find the measure of that purple angle, what I can do here is I can go about finding it 2 different ways. The first way might be the longer way, and what I could work with is the fact that I've got a little right triangle right here. And let me highlight it. So I've got a little green right triangle right here. So let me pull it out just so you can see it a little bit better. So this is C and D and F. And notice angle D here is 52. So I can use the fact that a triangle's angles add up to be 180. So I could either add 90, 52, and then subtract it from 180. Or I could also realize that the acute angles of a right triangle are complementary. Either way, but if you do it the longer way, 52 plus 90 equals 142. Then subtract that from 180. And then the missing angle C up at the top is 38 degrees. So this side of it is 38. Notice I've got exactly the same angle on the other side. So this side is also 38. So 38 plus 38, and the measure of BCD is going to be 76 degrees. Because the reason why these are two congruent right triangles here, I also have this one over here, is because I've got congruency marks, so I know that this is actually, if you think about this one, this is an isosceles triangle here. The faster way would have been to recognize that since these sides are congruent, then these base angles here are congruent. So this one's 52. So the other way to do it would have been to add 52 plus 52 and get 104. Subtract that from 180, and that would have gone right to the 76 degrees, which would have been this whole angle right here. So you could do it either way. So for the first one, it wants us to find the length of the mid-segment. It's giving me the measurements of the two bases. So remember the formula we're going to use, this is going to be my base 1, this is going to be my base 2. So I'm going to be using base 1 plus base 2 divide by 2. So I'm going to do 18 plus 10 divide by 2. 18 plus 10 is 28. 28 divide by 2. And the length of the mid-segment, which is MN, is going to equal 14. Now, if they give you the length of the mid-segment and one of the bases, like we're going to do on the next example, we're still using the same formula, but we need to solve for one of the bases. So again, this could be my base 1. This one right here, the 18.7, this is the length of my mid-segment. I'm looking for the base 2. And I'm going to call this X. So I'm going to go ahead and plug it into the formula. 11.5 plus X divide by 2 equals 18.7. I'm going to use my Algebra 1 skills to solve for X. I'm going to go ahead and multiply both sides by 2 to clear the fraction. And then now I'm left with 11.5 plus X equals 37.4. And now I subtract 11.5. And X, which is my other base, is 25.9. So base 2 here, or AB, is 25.9. So AB equals 25.9. And that is it for the notes on section 5.